So we have square root on both of those. Because they are both square root, what this means is I can do 2 over a, times b over 3. Okay? So that is the square root of 2b over 3a. Now, we will eventually start rationalizing denominators, and that's something that we'll do next week, is starting to rationalize denominators. But right now, we're just practicing with the product rule, and so we'll take this a little bit further next week. Okay, so our next one is we are going to talk about the quotient rule. The quotient rule. Okay? So as long as our index right here is the same, we can break this up. Okay? So we can go from the nth root of a over b equals the nth root of a over the nth root of b, or we can go this way. So we can move either direction here. If it's helpful for us to divide and then take the nth root, we can do that. If it's helpful for us to break it up and take the nth root of the numerator and the nth root of the denominator, we can do that. Okay? So let's do these. Okay. Now, I am taking the square root of 5 over 16. Can I take the square root of 5? No, I cannot. So I'm going to rewrite that as the square root of 5. Can I take the square root of 16? I can. So what is the square root of 16? 4. Okay. Okay. Now we're getting into some stuff that's a little different. So let's focus on this right here. I've got the square root of 40 over the square root of 81. Okay, I'm going to break that up into the square root of 40 over the square root of 81. Now, 40 is not perfect. Not a perfect square. Not perfect. Is 81 perfect? Yes, 81 is perfect. And so what is the square root of 81? 9. Now, 40 is not perfect, but there is a perfect square factor in 40. What is my perfect square factor in 40? Okay, 2 is not a perfect square, but what if I do 2 times 2? What do I get? 4. 4 is a perfect square. So what I want to do is I want to break 40 down. I'm going to break it down to 4 times 10. Okay? So I've got 4 times 10 right there. Can I take the square root of 4? I can. What's the square root of 4? So then I have 2 on the square root of 10 over 9. Okay? So when I do not have a perfect square inside my square root, always ask myself, can I break this down into a perfect square factor? And you always want the largest perfect square factor. And that's what this is right here. A perfect square factor of 40. Okay, and again, that is something that we will practice a lot more next week, is pulling out those perfect square factors. Okay. Let's do some more. Can I move off the screen? Okay. Now we are looking at cubed root. Is that the air? Or do you think it's rain? You think it's rain? Okay. I'm sorry? It wasn't raining. Okay. Okay. So now we're going to use the same rule, the quotient rule, and we're going to solve these. But notice that this is cubed root right here. So we're doing the cubed root. So what I'm going to do first is I'm going to have the cubed root of 27, and I'm going to have the cubed root of 64. Now, if we forget what cubed roots are, I'm going to list some of them off to the side. So 1 cubed is 1. What is 2 cubed? What's 3 cubed? 3 times 3 times 3. Good. What's 4 cubed? 4 times 4 times 4. 5 cubed? 125. Okay. So, can I solve the cubed root of 27? I can. So that's going to be 3. And what's the cubed root of 64? Good. Okay, so 3/4 is my answer right there. 3/4. Okay, now once we get to the 5th root, we've got to kind of think about what does that mean, the 5th root. We don't have 5th roots all memorized. So let's talk about how we're going to solve this one. I am going to go ahead and rewrite this as the 5th root of 7. Now 7 is prime. Is there anything I can do with that? No, I just leave it. So now I'm going to focus on this 32 right here. And I am going to break that 32 down into as many primes as I can. Okay, so I'm going to start with 32. And I'm going to break that down to 4 times 8. 4 times 8. Okay? Now, can 4 break down more? 2 and 2. Okay, what does 8 break down to? Good. And can I break 4 down again? Okay. So what I've done is I have factored this into primes. So 2 times 2 times 2 times 2 times 2. So I'm going to write that down right here. So I'm going to have the 5th root of 2 times 2 times 2 times 2 times 2. And then I've got x to the 5th. Now, I always pause right here. I always pause right here because I want to make sure what I wrote inside this radical, when I multiply it all together, equals this right here. So I say 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So does this right here equal 32? It does, okay? So now, because I am looking for a set of 5, I have 5 2's. And so how many am I going to pull out? Good. So I'm going to have 2 right here. Well, actually, in the numerator, I'm going to keep that right there. Okay? So I'm pulling a 2 out. Now, I have the 5th root of x to the 5th. What's the 5th root of x to the 5th? X. Okay? Because this and this are the same. So I'm going to have x right there. So that is my final answer. Okay. So now we're going to do some simplifying. So we talked about the product rule, we talked about the quotient rule, and now we're just going to start simplifying all of them. We're going to simplify all of them. Okay? So let's get started right here. Now we talked about finding a perfect square factor. So we want to find our largest perfect square factor. And it's got to be our largest. Sometimes it's pretty easy to see, sometimes it's not. Okay, we've already done the square root of 40, so what's my perfect square factor inside 40?
2 and 10. 2 or 10 inside 4.
Okay. I just want to know the perfect square factor of 40. It's 4. Okay? And you're correct. That's where we're going. Okay? So I'm going to have the square root of 4 times 10. And I can take the square root of the 4, and the square root of the 4 is 2. Now, let's say, what if I didn't know that? What if I did not know that 4 was my largest perfect square factor? So let's just say we weren't sure. Okay? So that's when I can do a factor tree. Okay? And I'm going to do 40. Okay, so then I'm going to look at 40, and I'm going to know 2 goes into 40. So then I'm going to say 2 times 20. Okay? Then I'm going to look at 20, and I'm like, oh, well, that's 4 times 5. Okay, and then I'll look at 4, and I've got 2 times 2. So this is a factor tree right here that I've done. So I've got 2 times 2 times 2 times 5. Okay? So this is an alternative to what we just did right here. So I can have the square root of 40, and then I can rewrite the square root of 40 using the 2, the 2, the 2, and the 5. Okay? So I've got 2 times 2 times 2 times 5. Okay? So this is an alternative. This one we found our largest perfect square factor. Here what we did is prime factorization. Now, there's square root, so how many do I need to pull 1 out? 2. So I've got 2 2's. So I've got a set of 2 2's inside. So I'm going to pull 1 out. And what's 2 times 5? 10. So there are 2 different methods to this. There's 2 different methods. One method, and that's what we used up here, this is what a lot of us prefer, is to find the perfect square factor. That's what many of us prefer. If we can't see the perfect square factor, or we're not sure what the perfect square factor is, then we could do the prime factorization and we get to the same thing. Okay? The biggest issue is that you've always got to find the largest perfect square factor. It's got to be the largest perfect square factor. Okay? Okay, so now we're going to do the square root of 300. Okay, is there a perfect square factor inside 300? And we want our largest. 100. 100. Good. No, 100 is our perfect square factor. Then we're going to take the square root of that. Okay? So 300 breaks down to 100 times 3. Okay? And the reason that this is important right here is it's our largest perfect square factor. Okay? And what is the square root of 100? 10. Okay, now, most students prefer this way. Most students prefer this way. Okay? But I'm going to show you, you can also do it with the factor tree. Okay? So we're going to do the prime factorization of 300. So this is just an alternative. This is just an alternative. So I'm going to have 300. Okay, I know that 2 goes into 300. Okay, so I'm going to say 2 times 150. Okay, 2 goes into 150. So I have 2, 75. Okay, 2 doesn't go into 75, but what does? Good. Okay, and then I'm left with 15? 15. Okay, and then what does 15 break down to? 3 and 5. Okay, so now the prime factorization, got it right here. That's my prime factorization. So I'm going to rewrite this. So I've got the square root of 300, and I'm rewriting this as the prime factorization. I have a set of 2's, then I have a set, then I have a 3, and then I have a set of 5. It doesn't matter what order that you write those in. I just usually write them in numerical order. So I've got my 2's, I've got my 3, and then I got my 5's. Now, I need a set of two numbers. So here I can bring the 2 out, and I can bring what else out? The 5. Okay? So, I've got a set of 2's and I've got a set of 5. So I'm going to have 2 times 5 on the outside, and what's left on the inside? 3. So I have 10 on the square root of 3. In general, what students do is they do the largest perfect square factor. This is the method that most students prefer until they can't figure out what the largest perfect square factor is. Okay? Then they do the factor tree. So if you're not sure what the largest perfect square factor is, you can always go over here and do the factor tree. Okay? Now, 15, square root of 15, does it break down into a perfect square factor? No. What are the factors of 15? 3 and 5. Okay? Is 3 perfect? Is 5 perfect? No. So that this does not simplify. Now, be careful, because simplify does not mean to use your calculator. Okay? The only time you're going to use a calculator is when the directions say find a decimal approximation. Now, you could use your calculator to figure out your perfect square factors. That would be fine. Okay? But you don't want to take the square root of 15 on your calculator, because then you're going to get a decimal approximation. And when we have simplified, that's not what that means. Whenever you need a decimal approximation, it's going to say find a decimal approximation, and then it'll say round to the nearest tenth or the nearest hundredth. Okay? Okay. Can I go to the next one? Okay. Now we're doing cubed roots. Okay? So when I'm doing a cubed root, how many sets of a number, or how many of the number do I need? A set of how many? 3. I need a set of 3. We do not know our perfect cube factors as well as we know our perfect square factors. So once we're doing cube root, 4th root, 5th root, I would encourage you to do prime factorization. So I've got my 16. So off to the side, I'm going to have 16. And I'm going to break it down to 4 times 4. And that's a perfect square, but it is not a perfect cube. Okay? So now what we'll do is we'll go ahead and break 4 down to 2 and 2. So those are my primes. So I'm going to rewrite this as the cubed root of 2 times 2 times 2 times 2. Here I'm looking for a set of 3. So there's a set of 3. So how many do I bring out? Good. So then I have 2 on the cubed root, and what's left inside? 2. Okay? Okay. Now our next one, the quotient rule allows me to rewrite this as the cubed root of 3 over the cubed root of 64. Okay? The cubed root of 3 cannot break down. Okay? We can't break the cubed root of 3 down at all. Okay? So our numerator is going to stay the cubed root of 3. You might remember the cubed root of 64. What is the cubed root of 64? It's 4. Okay? But what happens if we don't remember that? Good. Factor tree. If I don't remember the cubed root of 64 is 4, I'm going to do a factor tree. So I've got 64. Okay? I know that 8 times 8 is 64. Okay? But 8's not prime. So I'm going to say 4 times 2. Okay, 4 is not prime. So I'm going to say 2 times 2 and 2 times 2. I got a whole bunch of 2's there. So I can rewrite this as, and this is an alternative. You don't have to do it this way if you know the cubed root of 64. So I can rewrite this as 2 times 2 times 2 times 2 times 2 times 2. I am looking for a set of 3 because it's cubed root. Okay? This set of 3, I'm going to bring out a 2. And this set of 3, I bring out another 2. Is there anything left inside? No. Okay? So that's 2 alternatives to that. 2 alternatives to that. Okay. Now we're going to bring in our variables. Bringing in our variables. Can I go off this screen? Yep, okay. Okay, so here I've got x to the 7th. There is no number right here. So that means I'm finding the square root. Now we're going to do this a couple of different ways. The first way is I'm just going to write out x to the 7th. That's x times itself 7 times. 1, 2, 3, 4, 5, 6, 7, okay? And this is an assumed 2. We do not have to write the 2 there when we're dealing with square roots. Here's a set of 2, so I'm going to pull 1 out. Here's a set of 2, so I'm going to pull another one out. Here's a set of 2, so I'm going to pull that one out. But do I have something left over? Yes. So that is going to be the square root of x. So this simplifies to x cubed on the square root of x. Now, a better way to do that is if I am taking the square root of something. What I need then to take the perfect square of that is an even number. Okay, x to the 7th is not even, but what I need is an even number right there. Am I allowed to break x to the 7th up to x to the 6th times x to the 1st? Does that mean the same thing? It does. It means exactly the same thing. Now, how do I take the square root of x to the 6th? What's this? What am I going to divide the 6 by? 2, because I'm taking the square root. If I was taking the cubed root, what would I divide by? 3. Good. Okay, so 6 divided by 2 is 3. So I have x to the 3rd, and then I've got x left over. Okay? Okay. Now, I've got the square root of 20 over the square root of x to the 16th. What is a perfect square factor inside 20? 4. Okay, so I'm going to have the square root of 4 times 5. Okay, so I just broke 20 down to 4 times 5. Then I've got x to the 16th, and I'm taking the square root of that. There is an assumed 2 right here because it's square root. I don't have to write the 2, but that's what square root means. Is this already even? Good. So what is the square root of x to the 16th? X to the what? 8th. Good, because you are just dividing that 16 by 2. Okay, what's the square root of 4? 2. So I have 2 on the square root of 5 over x to the 8th.
Isn't the square root of 16 4?
Okay, are we talking about right here?
Yeah.
Okay, you are correct. The square root of 16 is 4. But I'm not taking the square root of 16. I'm taking the square root of x to the 16th. So what x to the 16th means is x written down 16 times. Okay, and so for every 2 x's, I pull 1 out. So when you have an exponent, that's when you divide. That's an excellent question, and that's also a common mistake. So great question. Okay, Okay, can I go to the next page? Okay. Now here, I am doing cubes. I'm doing cubes. Sometimes students are able to look at cubes and say, oh, that's a perfect cube factor. It's more difficult with cubes. They typically always do it with square roots, but cubes is much more difficult. So I usually recommend for students to do the prime factorization of these. 2 goes into 54. 2 times what equals 54? Good. Okay. 27 breaks down to 3 and 9. And so now I've got my prime factorization of 54. So I'm going to rewrite this as the cubed root of 2 times 3 times 3 times 3. Now, I am going to be dividing these exponents by what number? 3. I'm going to be doing it by 3 because I'm cubed root. If I was square root, I would divide it by 2. But I'm going to be dividing by 3 because it's cubed root. Is this exponent a multiple of 3? It already is, so I'm going to leave this one alone. Okay. Is this a multiple of 3? It is not. What is the largest multiple of 3 in 8? That's too big because it goes over 8. 6. So then I'm going to have y to the 6th, and then I have how many left over? Good. So I want you to look right here. Y to the 6th times y squared, is that the same thing as y to the 8th? It is. Okay. So now I've got a set of 3 3s right here. So I'm going to bring one of them out. Okay. What is the cubed root of x to the 6th? Not x to the 3rd, because I've got to do 6 divided by 3.
X squared.
Good. It's going to be x squared. Okay. What about y to the 6th? Y squared. Okay. So I've taken the cubed root of this, and I've taken the cubed root of this. What am I left with on the inside? You got it. Now, I want you to look right here. Do you see how this is an exponent that goes with this y? And do you see how this is my cubed root? Be careful there, because sometimes this exponent and this root runs together. Okay, yes ma'am. Say that one more time. Oh, good. So what I did right here, you're talking about this y to the 6th and y squared. I looked at this y to the 8th, and I knew that I was taking the cubed root of y to the 8th. So what I had to find was the highest multiple of 3 that was not larger than 8. Okay? So I did 6, and then because I knew that 6 could be divided by 3. Okay? Then once I got this right here, I had to figure out how many were left over. Okay? And that's how I got the y squared. So y to the 6th times y squared, that's how I got y to the 8th. Okay? That's a great question. Thank you. Okay? Okay. Can I go to the next page? We're doing a little bit more simplifying. Okay. This is the square root of 20 over the square root of 5. The way that I would do this one right here is I would rewrite this using the quotient rule as the square root of 20 over 5. Okay, the quotient rule allows me to do that. What is 20 divided by 5? 4. So then I have the square root of 4, and what's the square root of 4? 2. Okay, so remember, as long as they are both inside the square root, I can do that. Okay, I'm actually going to do the same thing with my next one. So my 7 is on the outside. So I'm going to keep that 7 on the outside. Okay. Then I've got the cubed root of 48 y to the 4th over 2y. So all I did was I kept the 7 on the outside, and then instead of having 2 radicals, I rewrote it as 1 radical. Okay? Now, inside this radical, this y cancels, and what would I be left with up here? Y to the 3rd. Good. Okay? Does 2 go into 2 and 2 go into 48? Does. 2 goes into 2 one time. 2 goes into 48 how many times? Good. Okay, so now I can rewrite this as 7 times the cubed root of 24y cubed. And that can be simplified. Okay. Because we're doing cubed roots right here, I like to use prime factorization. Okay, so I am only focused on what's on the inside. So I'm going to do the prime factorization of 24. Okay, 24 breaks down to 6 and 4. You could have done 2 and 12. You could have done 3 and 8. Doesn't matter. Okay, 6 breaks down to 2 and 3. 4 breaks down to 2 and 2. Okay, so I'm going to keep my 7. Well, actually, I'm going to just deal with my 24 y to the 3rd. Okay, so my 24. So I'm going to have cubed root of that. So I'm going to have the cubed root of 2 times 2 times 2 times 3. And then I've also got y to the 3rd. Okay, do you see how I've got a set of 2 2's? So I'm going to pull one of them out. Don't forget this 7 that's here though. Okay, do you see how this 7 right here was in my original problem? So don't forget about that. Okay, so then I've got a set of 3 2's, so I'm going to pull a 2 out. What about this right here? What's the cubed root of y to the 3rd? Good. Okay, and then what am I left with right here? Just 3. Okay, and I have one more thing to do. What do I need to do? Whoops. Good. So my final answer to this is 14y on the cubed root of 3. Now look at this closely right here. You got to be careful how you write that because you don't want this cubed root to look like it belongs to that y. Okay, you want to be sure that 3 is inside that index right there. Okay. Now we're going to start looking at the distance formula and the midpoint formula. The distance formula and the midpoint formula are both formulas that you will be given on your test 4 as well as your final exam. Okay? So this is your distance formula. So basically what the distance formula is saying is you subtract your x coordinates and square. Then you're going to subtract your y coordinates and square. Okay. Then once I've done that, I'm going to take the square root of their sum. Okay. When you are finding the distance between 2 points, you will always be given those 2 points. You'll be given those 2 points. So let's look at this. Is it okay if I go to the next screen? Okay? So what we are looking at is we are going to find the distance between these 2 points. Okay? -5, 8, -2, 2. This is my x coordinate. Okay? And it doesn't matter which one you identify as x sub 2 and y sub 2 and x sub 1 and y sub 1. It doesn't matter as long as you start with the same one. Okay? And so this would be x sub 1 and y sub 1. It does not matter which one's x sub 2, y sub 2, and x sub 1, y sub 1. You're going to get exactly the same answer. Okay? I am going to start with this coordinate right here. I'm going to start with this one first. So I've got the distance equals the square root. So I've got -5 minus -2. So I took this -5 and I am subtracting this -2. Okay? Then I'm going to do the same thing with my y coordinates. Okay? I start with 8 and then I subtract 2. 8 minus 2. And then I square it. Now, minus a minus becomes what? Addition. Okay? So this becomes -5 plus 2. What's -5 plus 2? What is it? Good. And then I'm going to square that. Then I've got 8 minus 2. What's that? Good. And then I'm going to square that. Okay. What is -3 squared? Good. It's +9. Okay. Your negative and your 3 is being squared. So we're going to have +9. Okay. What is 6 squared? 36. Good. Okay. And then I'm going to add those together. And I get 45. This can be simplified. Okay, so I need to simplify this. There is a perfect square factor in there. Does anybody know what it is? 9, good. Okay, so I'm going to simplify this. Okay, so I've got d equals the square root of 45. That does break down to 9 times 5. Okay, 9 times 5. And what's the square root of 9? Good. So I have 3 on the square root of 5. And that is my final answer right there. I predicted 11, didn't I? Okay. Our next one this is the distance formula. So the next formula we're going to look at is midpoint formula. Is it okay if I move past this one? Okay, here we go. The midpoint of the line segment, whose endpoints are x sub 1, y sub 1, and x sub 2, y sub 2, is the point with coordinates. So basically what you're doing, you add x coordinates together and divide by 2. That's what we're doing. Here, we add y coordinates together and divide by 2. Okay? It's important to realize that your answer is an ordered pair. Okay? Answer is an ordered pair. Okay? Is it okay for me to move off this screen? Okay, so x sub 1, x sub 2 divided by 2, y sub 1, y sub 2 divided by 2. So what I'm going to do is I'm going to take this x coordinate and add it to this x coordinate and divide by 2. Okay? So I'm going to have -5 plus -2 divided by 2. Then I'm going to take this y coordinate And this y coordinate, add them together and divide by 2. Okay? So negative 5 plus negative 2 is negative 7. So that's going to be negative 7 over 2. 8 plus 2 is 10. What's 10 divided by 2? Good. And that is my final answer.